So we're starting chapter 5 on quadratics. Don't let the word scare you. We in grade 9 you did all the linear stuff like drawing lines. So now in grade 10 we draw curves. Why are you guys crying already? Alright, so I'll try to make the math easy to understand. I'll do your language. So let's take a trip down to memory lane, back to grade 9 when we did first difference. Do you guys remember first difference? No? Okay, first difference is you take a look at your y column and you subtract. You subtract to find out what the difference is between your y values. Yeah, it is. So 7 minus 5 is 2. Yeah, see, it wasn't so bad. 5 minus 3, you get 2. No way, right? And 3 minus 1, guess what? Yeah. And then 1 minus negative 1? 2. 1 minus negative 1 is also 2. Right. What did you... The difference. Difference between your y value.
How is it? Oh, between just the y values?
Just the y values. Yeah, that's what you do for first difference. You only look at your y differences. All right. So fill in the blanks for me here. Since the first difference are the same, good. The relation is yep, linear, right? Linear. And the graph is a linear graph, which is straight line. That's right. All right. So as I said, this is based on grade 9. That's all we did for the whole grade 9 year is drawing lines. Okay. So what if we do this and it's not all the same? Yep.
Then we can subtract. We can keep doing the same thing until
Yes.
we find all the numbers.
Good. All right. Well, we don't keep going forever, but just doing it twice is good. All right. So 9 minus 4 gives us the 5. And then here, 4 minus 1 gives us 3. 1 minus 0 is 1. 0 minus 1 is negative 1. Negative 3. And negative 5. Okay. Do you guys see a pattern here? Yep. Okay. So I kind of see a pattern, but I see that my first difference is not the same. So we do what's called second difference. Okay. Second difference is basically doing the same thing, but from this column now. Yeah. Okay. So 5 minus 3, you get 2. 3 minus 1, you get 2. Do you see where I'm going with this? Yeah. So don't worry, if second difference is not the same, you don't have to do third difference. So all you're keep on doing is just seeing what the difference is between this first column, second column, and then here. Yeah.
Next year, are we gonna have to know like third difference?
No. Yeah. So that's all it is. After second difference, there's no more. No. Good question. Okay. So we're only calculating difference. Difference again means subtract. Okay, Rashan, you still with me? Rashan? Hi. Okay. I'll give you guys a second. Yeah. So all you're doing is so if first difference is the same, do I still need to do second difference? No, I can stop. But because first difference is not the same, I have to do second difference. Okay. And then if second difference is not the same, I stop as well. Like I don't have to do anymore. Second difference is 2. Yeah. And then here, let's make our conclusion. Gavin, can you help me fill in the blank? Help me fill in the blank first. So the first difference are not equal or different. Yep. Therefore, the relationship is, okay, Sydney? If the first difference is different, then, oh, sorry, different, not difference. Since the first difference are different, therefore the relationship is nonlinear. Right. Remember this word? You guys did it for like a whole semester. However, the second difference are same. So therefore, we say the relation is said to be, who knows the word? Linear is when its first difference is the same. Quadratic. That's right.
So what does that word mean?
The shape of the graph is called a parabola. Okay, so parabolas, I know you guys heard of this term before. So a parabola is a type of quadratic function. So a special type of curve. Gavin?
What happens if after the selected difference is not equal?
You don't do anymore. There's no further, yeah. So it's just neither. If it's first difference not the same, second difference not the same, then we just say it's neither. No, it's not linear, it's not quadratic, it's some weird graphs that has no pattern. Okay, so now let's look at some examples that shows parabola around the world. So as I said, I had this on the smartboard. I was going to do some more interactive stuff with you guys, but I wanted to record the lesson. So where do you see parabolas in real life? Yep. Jump rope. Good. Jump rope. I like that one. So a parabola is like something like this or like this. That's a parabola.
Sound.
Sound wave is actually a different type of graphs. You'll learn that in grade 11. Yeah.
Something flexible going against air resistance, like bend backwards.
Okay. But something simple that you see in everyday life.
Rainbow.
Rainbow. Good. Well, you have great ideas. Rainbow. Jerry, was it you or Andy? I saw a hand up over there.
Like the sails thing, where you see like the sails go up and down.
Oh, okay. That's good. Okay, so like
Like the stocks.
page 2. Right, but then for the stock is more like lines, so not really curves. Yeah. Trajectory, good. Yeah. Sorry. What? Magnet. Oh yeah, magnet. Projectile. So like when you kick a ball or you launch a rocket, we are gonna do a lot of those. Like in this, those are the word problems that you'll see. Okay. As can I say it? Magnet. All right. So I think we have the idea. I think we get the idea. Okay. So let's actually graph this. So the standard. So you know how in like y equals mx plus b, that's like the standard equation of a line. For quadratic, for parabola, we have this, y equals x squared. This is the general equation of parabola. Okay. Let's substitute these numbers in then. So y equals x squared. When x is -3, what's y?
9.
9. Good. So the coordinate here, -3, 9. What about when x is -2? 4. So the point -2, 4. When x is -1, Negative 1 square is 1. Negative 1, 1. Jaden, what about 0 square? Yeah.
That's definitely a number.
0 times 0?
Oh, that's what? 0.
0. Right, so 0, 0. Rashan, 1 square. 1 square, 1 times 1? Yeah, so then your coordinate here, 1, 1. Leandro, 2 square.
4.
Yeah, so 2, 4. And then Jonathan, 3 square.
9.
Yeah, so 3, 9. Okay, so what we just did was we did a table of value. So we can graph it down. 1, 2, 3, 4, 5, 6, 9, 10. Okay, so negative 3 and 9. Negative 2 and 4. Negative 1 and 1. 0, 0. Okay. And that. Okay. So should I take my ruler out and connect the dots? Why not?
Not straight.
It's not supposed to be straight. What did we just say? These right here, I'm looking for this shape. Like jump rope, a rainbow. So I should be drawing one nice smooth curve. Okay, so one smooth curve. Like this. Yeah.
It's absolutely nice like that.
It should. I don't need you guys to be artists, but I at least don't use your ruler. Yes.
Oh, you are.
Yeah, I know. In grade 9, I told all my grade 9s to use the ruler. In grade 10, yeah, we don't use rulers anymore. Because we're drawing curves. All right. What do you notice about this parabola? Like from the left side and the right side? They're equal. They're symmetrical. No. Yeah. So all the parabolas Leandro, great question. All the parabolas that we do in grade 10 are going to be symmetrical. Yeah. and one thing, this standard parabola. Right now we're using a table of value to graph this. Later on, you by the end of this chapter, you should be able to draw this in 5 seconds. All right, we're gonna draw a lot of these, so you should be able to draw this in 5 seconds, and I'll teach you the trick. Drawing parabolas. Yeah. Yeah. Are you really? Why did I do the 2-page? Oops. I just wasted a whole page then. Okay. Yeah. So just like that, you finish page 1 to 4 because apparently page 1 and 2 are the same as 3 and 4. Why did I do that? Yeah, so 1 and 2 is exactly the same as 3 and 4. Different. Okay, so on your graph, label the vertex and axis of symmetry. Okay, so let's figure out what is vertex. Which is? Okay, looking at that graph, yeah. I wouldn't say corner. The tip, right. Okay, so right here, looking at this, let's call this right here is my vertex. Does it have to be 0, 0? No. All right. Or the highest point. Good. Okay, so it's the middle point of your parabola. Okay, what about axis of symmetry? Symmetry. Think of the word symmetry. Oh, Jaden. Yeah. No, you know it. You know it. So think of symmetry. What does symmetry mean?
Y-axis. It's got to be on the middle because it's got to be symmetrical with everything on the left and right.
Perfect. Yeah. So that's my symmetry line. Good. And we can actually write an equation of the symmetry line. Well, I cannot see with that. Can you see? Oh, you can. Okay. X equals 0. Right? So axis of symmetry is like the middle line. Okay. And in this case, the equation of this vertical line, x equals 0. So let's actually write those definitions down. So in this case, so vertex, you can think of it as the middle point. Okay, in this case, it's 0, 0. Axis of symmetry, think of the middle line or the mirror line. And in this case, it's x equals 0. Right, so then? Okay. So this is where we're gonna, this is the next part is what Leandro said. So if my parabola opens upwards, alright, let me just zoom this out. If my parabola opens upwards like this, alright, the y value of the vertex is what? Leandro, you were saying? So if this is my parabola and opens up, this point right here, that's the vertex, and also is this the highest or lowest? Lowest point, so it's the minimum value.
Wait, so it's always either the lowest point or highest point?
Yeah. Okay, similarly, William, you had your hand up. If my parabola opens downwards like this, then this would be the maximum value. So your vertex is always, always, always either your highest or your lowest point, because your parabola doesn't go zigzagging. Right? And so the general one, our y equals x squared parabola, the general parabola, which way does it open? Ethan? Up. Yeah. And therefore has a minimum. Good. And that value is 0. Okay. Yeah.
How much formula do we have to know?
For this chapter 3. Okay, so we're gonna take a look at the first type right here. First type. All right. Y equals x squared plus k. So this is the first type. Okay. So for the first row of all these pages, I'm gonna ask you the general one. So for y equals x squared, we know what it looks like now. We know that's the easy one, the basic one. So what's my vertex? Yep, 0, 0, right? Equation of axis of symmetry. Yep, yep. Direction of opening opens up, and how does it change from y equals x squared? Nothing, because it's just this one. So for x squared plus 2, take a guess. How do you think it changes? Okay, Adam? What? So what happened to your parabola?
Because you're adding 2 to
Yep. So
y, so it's
what happens to this one then?
It moves up by 2.
Up by 2. Good job.
Oh, good job, bro.
Yeah. So all it does is you shift the whole parabola, not just the vertex, but your whole parabola up too. So then with this new point right here, then this would be 0, 2. So Tayden, where is my axis of symmetry?
Is on 2 because the x equals to 2. Totally wrong according to the
Okay, so looking at this graph right here, where is the middle?
Oh, it's on the y-axis.
Right. So did it change?
Yes.
Looking at this and this, this is my axis of symmetry. This is still. Yeah. So equals x squared, right? Y equals x squared and then plus 2. Okay, and then you can see now the if you take a look at both of these, this is exactly, yeah. This is the first type. Our first type, my axis of symmetry doesn't change. It's still because I'm just moving the whole parabola up. All right. The next. So what do you think? Number 3 then. For number 3. Yeah.
We have to like make a drawing with.
Yeah, but that's later on. We're kind of starting to learn about that now. Okay. So what do you think? What do you think happens to this one then? Andy.
Vertex is 0, 5. The axis x equals 0. It opens up and it moves up by 2 compared to y equals 0.
Right. Good job. Okay. So let's do this one instead then. Number 5. So what do you think x squared minus 4 does?
Hey man, what are we doing, bro?
X, y equals x squared and then minus 4. Minus 4, what do you think it will do? Move down. By how much? Does it open up or open down? So who says up? Who says down? Let's find out. Still opens up. Alright. Again, all you're doing is you're shifting the whole red graph, the whole parabola up and down. Alright, so the shape, everything stays the same. You're shifting it just up and down. So this one right here, your parabola looks something like this. And this is at 4. So down 4. What's my vertex then? At -4. But I need a coordinate. 0, -4. Good. Is -4, 0 something totally different?
Yes.
Yeah, so make sure you don't tell me don't mix up the thing, the order. Okay, as we said, we know that this all of these opens up. Okay, what's my axis of symmetry here? Ethan, still x equals 0, right? All right, again, we're just moving it up, down. You're just moving the whole graph. So showing here. See, all 3 formulas right here. If it's plus, I'm moving it up. If it's negative, I'm moving it down.
Yeah, but you've got up for -4. It's always up.
It's always up.
Upwards. It is direction of the opening of
Yeah. So your graph is still opening up. Okay. Okay. Let's do this. Okay. So second type. As I said, there's 3 types. So let's see if we can get through all 3 types. Since I have the full house today, I want to make sure we can do this. So this is the second type now. We have brackets. What happened to the what happened to the sun? All right, so this time we have brackets. I just realized I photocopied the wrong layout for you guys. It's okay. All right, so now with brackets, how do you think it's gonna move? How do you think it's gonna move? So let me take these 2 out. Let's put a new one. William, your guess.
My guess would be that it continues to move up and down.
Okay, so but then if it continues to move up and down, then how is this a different format than the first one? Andy?
With brackets, it's affecting the x-axis.
So instead of up down, it's gonna move left right. Okay, but here's the tricky part. X plus 2. Just we're just guessing it right now. All right. Who's guessing that? X plus 2. We go to the left. To the right. Okay, and the others are too scared to guess. Let's see. It goes to the left. Left. Yeah.
What is? I was gonna go left, close my eyes.
Yes. So it is a little tricky here. So if it's plus 2 inside the bracket, it's actually going left. And left by how many? 2. Yeah, so it goes to negative 2 here. So what's your vertex? Negative 2 and 0. Good. All right, so I guess the easiest way to think of it is it's the opposite sign. So if this is plus 2, then it goes to the left, so negative 2. The reasoning for that, the reasoning is you're figuring out what x equal. So if x is negative 2, negative 2 plus 2 gives you the 0. So that's the reasoning behind it. Okay. So this time, where is my axis of symmetry? Ethan. Right, my axis of symmetry, my middle line is right there. So x equals negative 2. Okay. Does it open up or open down? Still opens up. And is this a minimum or maximum? Minimum. Okay. Yeah, meaning. Okay, so what do you think this one is then? X minus 4.
Up and down, doesn't that say the same thing? So down is always x, and up is always x. 4 minus 4. So then why do we even put them both? 4. Negative 0.
So which way does it go?
4 negative 0. The other side.
Just to the right.
Other side. On the side.
Yeah. So 4, 0. Yeah. Okay. So x minus 4 means that it's gonna go to the right by 4. Okay, so this one 4, 0. It's the same thing. Yeah. Okay, so this is left 2, and this is right 4. Sorry. You're not used to it, eh? Alright. And what is my axis of symmetry here? Andy.
Let me see. 4.
X equals 4. Good. Nila. Does this open up or open down? Up. Yes. And because it opens up, this is a minimum value.
It goes down, it's not.
How are we doing so far?
I don't know if there's a worded way that I
Alright. So Tayden, just to show you again, this first format, this first format, y equals x squared plus k. So whenever you see a plus or minus a number afterwards, then you know it goes up and down. When you see brackets like this, then you know it goes left or right. So brackets tell you to move the parabola left or right. Y is just a type. And then this last type right here, final type, y equals 8x squared. So we did up, down, left, right. What could this be?
upside down.
Upside down. All right. Also, one more. One more thing though. All right. So we'll see what it does. So this first one, y equals 2x squared. So let me take out these graphs again. So y equals 2x squared. Okay, if I add a 2 in the front, I guess we're just guessing right now. What do you think will happen to my parabola? Positive 2 will flip it? No. So what would the 2 do then? Sedan? Is your hand up? No. What do you think the 2 will do? And Andy.
Maybe it become like thinner.
Thinner. Let's see. So let's see what happens to our graph. You are right. Why is it out of all the colors? Why is it? I don't like the red color. Sorry. There we go. Okay. Yes. So it's skinnier. Okay. But skinny doesn't sound mathematical. Okay. So narrower and more. Think of an elastic band. All right, when you pull it, it gets skinnier, so it's stretched. We say it's stretched. Okay. So on the test, if I just ask for a sketch, you can just do a like quick little sketch to show that it's skinnier. Okay. Stretch. Uh, I can maybe. Okay, so looking at this graph right here, what's my vertex? This is the last type, by the way. Okay. So looking at this graph, what's my vertex? Sydney. 0, 0, right? Because to stretch something, you don't move that middle point. Because if you move it, it doesn't stretch. Right? Axis of symmetry. Yep. X equals 0. Does it open up? Open down? Up. Since it opens up, this is the max or min? Min. Alright. What if it's a fraction? So the opposite of stretch, it gets bigger, fatter. But on the test, do you say my parabola got fatter? So 1 over 2. Yeah, it's wider. I'll do 1 over 4 so that you guys can see it more dramatic. Same. When I say fraction, though, it's between 0 and 1. So between -1 and 1. Okay. So if it's a fraction like this, then it's wider, it's fatter. So I was using the elastic band metaphor. So when you stretch it out, it's skinnier. So when you press it down, what do we call it? What word do we use? Compress. Excellent. You have to volleyball me? Oh, wait. 30 seconds. Compress. Excellent. So for this one right here, again, you can draw it dramatic. No, I thought she had. Okay, it's compressed by a quarter. Okay. So Gavin, yo, what's my vertex? 0, 0. Where's my axis of symmetry? Axis of symmetry? X equals 0. That is 5. Does it open up, open down? Up. And so it's a min or max? If it's up, that's a minimum. Okay. Yeah. Okay, so very last one, -2 then. -2, what do you think it does? Flip. Okay, so let me do these different type here. Whoops. Okay, and then this one. So finally, this one, y equal -2x squared. We have this upside down one. Okay. So when is it upside down? William?
When it's a coefficient times a variable.
Right, when it's negative. So the negative here tells you that it goes upside down. Okay, so you can say flipped, but formal word, reflected over the x-axis. Okay, so I don't mean to use difficult wording, but in grade 11, you're gonna do reflected over y-axis. So that's why I'm just using these terms now, so that you guys are used to it. So basically, reflected over x-axis means just flipping it. Okay, but that's the proper term. Other than reflecting over the x-axis, what also happened? Because of the 2 as well, so it's also stretched by 2.
And guess what? This is max.
And good. Okay, what? Rashawn, direction of opening?
This is
Opens.
max.
Yep, opens down. So this point right here, it's a max. Okay, what is the axis of symmetry? This middle point, 0, 0, x equals 0. All right. Okay, so very long lesson today. I'm sorry. Those are the 3 types. Your homework tonight is to do the rows that we didn't do. Okay, so any rows that we skipped, just do those up to page 8. Tomorrow, at beginning of class, we're gonna recap the 3 types together, just conclude together, and then if you look ahead, we have a combination of all 3. Okay, so by the end of tomorrow, you will be able to draw these. Okay.